Alright, in this video we're going to talk about logarithms. We're going to introduce the idea of what are called logarithms. Now, first we're going to begin with a definition. Logarithms are related to our exponential functions that we've talked about already, because logarithms are actually the inverse of an exponential function. So the notation for a logarithm is log base b of x. Log sub b. So just like in an exponential function, the b here is the base. And so log base b of x is equivalent to the exponential form x equals b to the y. Okay, so we have this relationship, which actually makes this logarithm thing over here the inverse of this exponential expression. Okay, and this is called a logarithm. We're going to use this relationship, this understanding, to help us understand what logarithms actually tell us. And so what a logarithm is telling us, since if y is equal to log base of b to the x is equivalent to saying x is equal to b to the y, what a logarithm is basically asking is what power must we raise the base b to get in order to get x. Alright, so what power must we raise b to get x? If that's equal to y, then b to the y is equal to x. And so a logarithm is asking the simple question, what power must I raise the one thing to in order to get the thing on the inside? Which is exactly the opposite of an exponential function, where in an exponential function we raise the base to a power to get some answer. Now we're turning it around and saying, what power do I have to raise b to in order to get x? So let's look at a few examples here to get a feeling for what logarithms actually do. Again, they're asking the what power. So it's kind of in a similar sense what the square root did. Right? What number squared gave us this answer? Cube root. What number cubed gave us this answer? Now we're asking what power must we raise 4 to, in this case, to get 16? And the answer is 2. And the reason it's 2 is if we turn around, we know what it means to square something. 4 squared is 4 times 4 is 16. So log base 4 of 16 is equal to 2. So very important for working with logarithms is understanding all the different little exponent properties and stuff that we had previously, as they're going to come up in these problems. Consider another example. Log base 5 of 125. Right? What power must 5 be raised to give us 125? Well, here if you're not sure, just start thinking about powers of 5. 5 to the first is 5. 5 to the second, 5 times 5, would be 25. 5 to the third would be 5 times 5 times 5, which would be 125. So therefore, log base 5 of 125 is equal to 3. And again, that's because when we take 5 and raise it to that power, we get 125, and that's what the logarithm's asking. Our next example, we throw something a little weird out there. Log base 2 of negative 4. And say, what power do I raise 2 to in order to get an answer of negative 4? Well, it turns out that's not real. And it's not real because the equation 2 raised to a power would never be equal to negative 4. Right? Remember, our exponential functions have graphs that look like this. Right? They're never negative. So there's no way that 2 to the x could ever be equal to negative 4, at least not in the realm of real numbers. Now, if we bring in imaginary and complex numbers, that's a whole different ball game, and it gets a whole lot more complicated. So we're going to avoid that. So it's impossible for positive 2 being raised to a real number power to ever turn negative. The graph never hits there. And so therefore that never happens. And so logs of negative numbers are undefined. Also, going back to my graph here, logs of 0 would be undefined because the exponential function there is never going to hit 0. So logs of negative or 0 would be undefined. Okay, and then let's continue now with some other examples here A little bit more difficult now. Log base 9 of 3. All right, what power do I have to raise 9 to in order to get 3? Well, taking 9 to integer powers isn't going to work. 9 to the first, 9 to the second, 9 to the third. None of those are going to get 3 because 3 is smaller than 9. But you might recall that fractional powers will do the trick for us. Because remember, raising 9 to the 1/2 is the same as doing the square root of 9, which is 3. So it turns out log base 9 of 3 is 1/2. Log base 9 of 3 is 1/2. And then in a similar manner, consider the problem log base 2 of 1/16. And this is where you have to remember your idea of how negative exponents work. So that's going to be -4 because remember, 2 raised to the -4th power, negative exponents would bring it down to the bottom, be 1 over 2 to the 4th, which would be 1/16. So log base 2 of 1/16 is -4. And then one last question here we throw out. I had to carefully choose each of the ones up above. Carefully choose each of the problems up above so that we would get an actual result. And this last one, though, I just kind of threw out there. Log base 6 of 7. There's no nice answer for this question. Log base 6 of 7. Right, what power do I raise 6 to in order to come up with the number 7? It's not going to be a nice whole number power. It's not even going to be a nice fractional or even negative power. All right, we're going to have to wait on that until a little bit later. We're going to have to hold off on that until a little bit later. And so we're going to develop some more things with logarithms so that later we will be able to answer this question.